All right, so today we will convert radians to degrees and also look at coterminal angles, find coterminal angles. Yesterday we learned about radians, and we know that uh, 0 and then this will be pi radians. If you go around this far, it's pi. If we went all the way around, it'd be 2 pi. And then we have, that's 1/4. Here's 2/4, 3/4, 3 pi over 4. This would be 4/4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and there's pi over 2. So those are special angles, and we can also go 0 to pi, and then we'll divide it into sixths. And so if each one of these is 1/6 of pi, we have pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6, back and all the way back to 2 pi. We can convert without graphing, but I think it's helpful to start graphing. And we look at, here we're rotating negatively, so we're going to go 1 pi over 6, and we'll go right there. In degrees, we can look at this. We know each of these angles is 30 degrees, so we know the angle is negative 30 degrees. Without a graph, we would do negative pi over 6. That's radians. We want to cancel the radians and be left with degrees. So we have 180 degrees over pi radians. And the pi's cancel. 180 over 6, negative 30 degrees. Here we have, why don't you try these 3? Pause and try these 3. Two pi over 3 is 4 pi over 6. So when you're trying to graph a multiple of pi over 3, just turn it into a multiple of pi over 6, and then you can count. We need 4 of them, 1, 2, 3, 4, so we know we're going there. And then we can see that it's 30, 60, 90, 120. So we know the angle is 120 to show the work. We have radians times 180 over pi radians. 180 divided by 3, 60 times 2, so that'll be 60 times 2 is 120. Seven pi over 4. So we count 7/4. 1, 2, 3, 4, 5, 6, 7. So we're rotating all the way around there. And we could count by 45s, and we would know that the answer is 315 degrees. So here we have radians, we have pi canceling, radians cancel. 180 divided by 4. We get 315 because it's 45 times 7, so we get 315. Here we're just counting by pi over 2, so negative pi over 2, negative 2 pi over 2, negative 3 pi over 2. We're rotating there, and that would be negative 90, negative 180, negative 270. So we have 180 divided by 2 is 90 times negative 3, negative 270. Okay, here's a new vocabulary word called coterminal. So terminal is ending and co is together. We want angles that end together. So let's graph 30. So we know that negative 30 is right there. And then we want a positive and a negative coterminal angle. We need another angle that ends right there. So we could do a negative rotation like that, and we would go 360, and that'll be a negative 390. And we want to end there, and we could start with a positive rotation and just see how far we rotated. And that will be almost a 360, 30 less than 360, so that's a 330. So those are that's the positive and the negative. And then we see that we are just adding a multiple of 360 or subtracting a multiple of 360. And we could do it over and over. We could go around twice and then in there, or go around 3 times. There's infinite coterminal angles. So to represent all coterminal angles, we could say it's theta such that theta equals 5 pi over 6 plus 2 pi n, where n is an integer. And that's set builder notation from chapter 1. You don't have to start with 5 pi over 6. You could have, I put that in radians. We could also say this. Theta such that theta equals let's change this. This is not 5 pi over 6. It is 11 pi over 6. 11 pi over 6 plus 2 pi n, because that's the 11 pi over 6. So let's do it with degrees, and we could just say it's theta is 330 plus 360 n. N is an integer. So we could say it either way. All right. So we have to graph 5 pi over 6. We just count 5 of these. 1, 2, 3, 4, 5. So there is the angle, and then we'll do a positive and a negative angle. We need to end there, and we could do and rotate negatively to end there, or we can rotate positively. This is 1, 2, 3, 4, 5, 6, 7. Negative 7 pi over 6. We need to end there. We could rotate around and then stop there. We've already done the 5 pi over 6. So there's 5 pi over 6. We wouldn't want to do that again. That's the same angle. We need a coterminal, mean another angle that ends there. So this is going to be 12 pi over 6, 13, 14, 15, 16, 17 pi over 6. Theta such that theta equals 5 pi over 6 plus 2 pi n. N is an integer. Okay, do the same thing with 240 degrees and negative 5 pi over 4. Pause the video and try that one. .240 is not a multiple of 45, so it is a multiple of 30. That means we know we need to draw this graph. And that's going to be 30, 60, 90, all the way around to 180, 210, 240. So we know we're going there, and that is 240 degrees. Let's draw a negative coterminal angle. We have to end there, and we need to rotate negatively. So we'll go like that, and we can count 30, 60, 90, 120, negative 120. Again, we're going to end there, but we need a positive coterminal angle. So we've already done this much. That's the original 240 degrees. So we'll go around again, and we'll just count how much that is. This is 360, 390. We're counting all the way around, adding the 30s, and we end up with 600. And to write that in set builder notation, we'll say theta such that theta equals the starting value plus 360n, where n is an integer. Negative 5 pi over 4, we're going to rotate 1, 2, 3, 4, 5. Negative 5 pi over 4. And we need to end here with a positive angle, so that'll be 1, 2, 3. 3 pi over 4 is coterminal. We have to end here with a negative angle. That was the original angle, so we have to go around again and just count how many fourths that is. So originally we were at negative 5, 6, 7, 8, 9, 10, 11, 12, 13 pi over 4. Negative 13 pi over 4. So we have theta such that theta is, we could start with negative 5 pi over 4, or even you could write 3 pi over 4 plus 2 pi n, where n is an integer. And that's it for today.